This video is about a simple and low-cost solar pumping system that we are testing here in Senegal. Behind us is the Gambia River, which is a potential source of water for irrigation, and we want to use this system for irrigation. First, a little bit of background. As most people know, the price of solar panels has come down dramatically in the last couple of years. So this is what many of us have been waiting for a long time, for the price of solar panels to come down so that they could be used in many more applications. And now at last it's happening. But this means there's some catching up to be done so that the other materials that go along with solar panels can also be reasonably cost so that the overall system will not be too expensive. In the case of solar pumping, there are some very good, well-made, reliable solar pumps on the market, but they're very expensive. So a typical system now would be in the thousands of dollars, even though the solar panels that are part of the system might be a few $100s. You might still be paying thousands of dollars for a complete solar pumping system, including electronics and so on. In some situations that might be necessary, but what we're hoping to do is to demonstrate a system where at low cost anybody can put together the components for a simple and reliable pumping system. So what we've done here, first of all, let's look at the panels. In this case we have 5 times 80 watts, a total of 400 watts of panels mounted on a specially made wheeled cart. The cart was made in the nearby town of Kédougou. It took about a day. It cost about $130, including all the materials and workmanship to put together this cart. Now the cart serves several purposes. Let me demonstrate that. Stand back a bit, please. The cart is quite light in weight, so one person can easily push it around. I'll just remove what's blocking the wheel here. And we want to move it around for several reasons. First of all, the irrigation site will be some distance from where people are living, and if it were left outdoors at night, the panels could easily be stolen. So with this system, it's very easy to roll the panels back to a secure location in the evening. Besides that, it's easy to move the panel into the sunlight a few times a day, not constantly, but a few times during the day. The position of the panels can be changed to avoid any shadows from trees, and even to optimize the output of the pump, because besides moving the panels, we can tilt them. So, for example, in the morning hours we can tilt the panel towards the rising sun, in the evening hours towards the setting sun, and in midday we can leave the panels in a more or less horizontal position to capture the maximum sunlight at midday. So in other words, it's a manual tracking system. The cart allows us to do manual tracking of the sun, and that should give us an increase in output through the day of maybe 20 to 25% extra output. And also for this pumping application, it means that the output of the pump will be more constant during the pumping hours. It won't be completely constant, but it will be for at least 6 hours of the day. As long as we can orient the panels towards the sun, we should have a fairly constant pumping rate for several hours of the day. let's talk about the pump now. As I mentioned earlier, panels are cheap and easily available. Even here in Senegal, in the nearby town of Kédougou, there's at least 6 roadside shops that are selling panels similar to these, which people are placing on their rooftops to have a little bit of electricity in the house. So the technology is widespread now, it's familiar, but as I said, what's missing are some of the other equipment to go with solar panels to make it more useful. In the case of pumping, I set out to find a cheap and reliable pump that could be directly connected to solar panels, preferably without batteries. Batteries would be an extra expense and extra complication that we would prefer not to deal with. I did some research and I found that one of the applications where relatively cheap and reliable pumps are being used is marine bilge pumps. So I searched around. There are many models available. The problem with most bilge pumps is that they're designed for very low head, in some cases just 1 or 2 meters. But after some searching, I found this particular model, which is a well-known brand of marine bilge pump. The company is, at least the brand name is called Rule. The company has changed hands a couple of times. I'm not sure who owns it now, but these pumps have been manufactured in the same form for years, and it's a proven, reliable design. This one is called the Model 4000, which means it's supposed to deliver up to 4,000 US gallons per hour, which translates to about 15,000 liters per hour, which is quite a substantial output, except that you only get that when your height of pumping is 0, which of course is never the case. In our particular case here, the garden site, we're not in the garden site, but it will be in a place similar to where we are. We're about 4 meters above the level of the river now. And the river will continue to recede during the dry season, so we might have a total pumping head of 5 to 6 meters. And that's assuming that we can keep the losses in the pipes to a minimum, hopefully less than a meter. So this particular pump can pump up to a total head of about 8 meters, and that's the main reason why this one is of interest for irrigation, whereas most of the smaller bilge pumps, the head is just too low. So this one we think it can do the job. We're still in the process of testing it. There may be other ones out there. I'm still looking myself that will have even better characteristics in terms of irrigation, but this one looks like it might do the job in certain situations. So it's a very simple pump. There's a removable trash screen on the bottom, and here is the pump impeller, which spins when it's turned on. So it sucks in water through this opening. The water goes into an inner housing, and it comes out through this outlet to which we've attached a flexible pipe. So this is easily removable to inspect the pump or remove any trash that might be blocking the inlet. So inside there's simply a sealed DC motor with the impeller attached. There are 2 leads coming out. There are no electronics. It's a brush motor, no electronics. That means that the lifetime is limited. Somewhere in the literature it talks about the number of hours of use that you can expect from this pump. I can't remember exactly the number, but it would basically correspond to about 1 year of daily use during daylight hours. And if this pump can give us 1 year of continuous use, we'll be satisfied. Because this pump, according to our estimation, could irrigate about 1/2 hectare of garden, and the revenue from that garden could easily pay to replace the pump on a yearly basis. And incidentally, The main advantage of this system is that you don't have to buy fuel. I guess that's kind of obvious, but if somebody were to, the alternative to this, which is currently available around here, would be a small gasoline-driven pump, which you would be spending several dollars a day for fuel. So just what you spend on fuel in a year would come close to the entire cost of this system, which doesn't use any fuel. The pump itself in North America is less than $200. The panels here, 500 watts, which is probably more than what 400 watts. It's probably more than what we actually need for this pump. In areas where there's competitive pricing, panels can be bought now for $1 per watt or less. I paid a little more for these because I didn't have time to look for the cheapest source of supply. But if we say that the panels cost $400, the cart costs $150, the pump costs $200. We're up to $750 now. Add the pipes depending on your situation. So for under $1,000, we have a complete solar-powered pumping system, as I said, that should irrigate about 1/2 hectare with zero fuel costs. Although, as I said, we may expect to replace the pump possibly on a yearly basis. The panels should last much longer than a year. There's no electronic controller, there's no electronics of any kind in the system. There's a simple switch and circuit breaker, which is just a normal household circuit breaker that costs $6 or something like that. So there are no complex electronics that can fail or that would have to that would need a qualified technician to repair or replace. Let me explain a little more this gadgetry surrounding the pump. It looks complicated, but it isn't. As I mentioned, the pump is only that. So we could put this directly in the river and it would pump water. That's all we really need. Why we've added a few bits and pieces here is to give the pump some protection. So the pump is sitting inside a rubber bucket, which will avoid putting it, for example, in the muddy bottom of the river. It should reduce the amount of trash and debris coming into the pump. So the pump will be immersed in water, but within that bucket. And then this tube, which is a motorcycle tube, is attached to the bucket to keep it floating at the surface. So that will, as I said, reduce the trash coming into the pump. It also will keep our electrical connection out of the water. This is the cable that will bring the power from the solar panels, and it's connected to the two-wire leads of the pump through a simple screw connector. I wasn't able to get a proper waterproof connector here, but I simply used a screw connector, and I've covered it with waterproof glue that should protect it to some extent from water. But in any case, we'll try to keep that connection out of the water. If it gets splashed from time to time, it's not a problem, but we're not going to immerse this connection in water. So by attaching it to the handle of the bucket, this electrical connection will remain out of the water while the pump will always be in the water. You can see why I'm wearing rubber boots. We're at the bank of the river. The pump is now floating inside its bucket within the river. So the pump is immersed in water and it's ready to start. And the outlet hose is connected. The outlet tube is filling up with water. There are enough holes in the bucket that the water keeps flowing into the bucket. and keeps it full of water. And this is how we expect that the pump will spend the whole day like this, pumping water. So here we are pumping water. So far so good. And we're going to use this bucket just to estimate the flow rate coming from the pump. What we're doing now is estimating the output of the pump. This is very crude, but we have somebody up the tree holding a pipe. So the outlet is about 4 meters off the ground. So now we have a total of about 8 meters of head. And as expected, the flow rate is reduced as compared to what we were getting at ground level, but there's still a reasonable rate of pumping, and we'll use that to make some calculations of the area that can be irrigated.